Yes, good evening all. Good evening to all. So, I am Naren Vishwakarma, uh, PhD scholar under PMRF scheme in at the Department of Electrical Engineering, Indian Institute of Technology, Indore. So, I will be taking a week 7 of the Principle of Communication Systems Part 2. So, let's begin with problem number 1. Okay. So, in problem number 1, we have considered a discrete memory source X with symbol SI, where I is 0, 1, 2, 3, with four possible binary codes that will be S0, S1, S2, and S3, which are given in this table. And we have to find the codes, that is code A, code B, code C, and code D. There are four codes, and the corresponding symbols or the binary symbols S0, S1, S2, S3 are coded in this way as given in the table. So you have to find the codes which satisfy the Crafts inequality, and you have to find the codes which are uniquely decodable and which are not. Okay, you have to find the codes which are uniquely decodable and which are not uniquely decodable. Okay, you know the Crafts inequality. Yes, everyone knows the Crafts inequality. What does it say? It's Crafts inequality. I will write the Crafts inequality for you. So Crafts inequality says that sigma I equal to 0 to n minus 1 2 raised to minus I, we should be less than or equal to 1. If we say that 2 raised to the individual code length raised to minus of that individual code length, and we have when we sum them, it should be less than or equal to 1. Okay, so you have to find the which of the given codes, that is, let's say code A, code B, code C, and code D, which of these follows this Crafts inequality. So you have to put the value of I equal to, actually here n is 4. Okay, 4 symbols, 4 binary code. So for all codes m is 4. And what is the value of I? Sorry, one thing I have written wrong, actually notation. It should be minus of L code lengths, L1, L2, L3 up to L of m minus 1. Length, it is actually length. Yes, code A satisfy the Crafts inequality. Yes, anyone? Have you calculated? What is the length? Length here. So length of S naught is 2, 2, 2 and 2. Clear? Let's say copy here, paste here. Now it is visible. Okay, so what I am trying to do, I will write, the number of length of the respective code. So that is nothing but what is the length of the code? 2 bits are there, so 2 for this symbol. Length is 2, 2 length L. So for corresponding to L of B, so this is 1 bit, so this will be 1. This will be 2. 2 bits are there. There are 3 bits, so length is 3. So here also the length is 1, 2, 3, and 3. Here for code D, length is 1, 3, 3, 3. Yeah. So length of length for A, length of B, C, length of D. So for code A, for code A, we will calculate the Crafts inequality. Let's say K equal to sigma I equal to 0 to m is 4 here. So m is 4 here, so it will be go from 0 to 3, 2 raised to minus L of I. That will be so here length L0 is 2, L1 is 2, all are equal, L2, L3. Clear? So it would be 2 raised to minus L naught, that is minus 2, plus 2 raised to minus 2 plus 2 raised to minus 2, 4 times. So 4 into 1 by 4, that is equal to 1. So it satisfies the Crafts inequality. Clear? Because this is equal to 1. And what we have to do, what we have to see, we have to see that sigma this 2 raised to minus Li should be less than equal to 1 for Crafts inequality. Clearly? So for code A satisfies, yes, it satisfies the Crafts inequality. Similarly, for code B, this factor K would be, what is the value of this factor K? 2 raised to first length is 1, so that is minus 1, plus 2 raised to minus 2 plus 2 raised to minus 2 plus 2 raised to minus 3. So calculate it. I'm not calculating, I'm directly writing now. It would be 9 by 8. 1 plus 1 by 8, that is 9 by 8, which is greater than 1. We can see 1 plus something. Okay, so it is greater than 1. So it does not satisfy the Crafts inequality. It does not satisfies Crafts inequality. Clear? For code C, similarly for code C, yes, have anyone has calculated what is the value of K here? What is the value of K here for C? That would be 2 raised to minus 1 plus 2 raised to minus 2 plus 2 raised to minus 3 2 times. That would be, I think, 1. So it also satisfies the Crafts inequality. Yes, it is fine. Code D, understand? Now 1 2 raised to minus 1 plus 3 times 2 raised to minus 3, that would be 7 by 8. Okay, 7 by 8. 7 by 8, which is less than 1. So Yes. So except B all satisfies the Kraft inequality. Clear? Now the second question is find the codes which are uniquely decodable and which are not. So how to find whether the code is uniquely decodable or not? Yes. How can you find whether a code is uniquely decodable or not? Yes, anyone? Then
Uh, one code should not be prefix of another code.
yes, yes, yes.
Yes.
It should be prefix free code.
Prefix free code, yes.
Yes. So prefix free code will not are uniquely decodable. And if one symbol or one code is prefix of another code, then it will not be uniquely decodable. Yes, correct. So let's again copy this one here. So what is the criteria for prefix free code? So criteria is the code should be prefix free. So prefix free codes are uniquely decodable. That we should remember. Yeah. So first we will see the code A. Code A. So any code is a prefix of another code? No. So this is unique, this is unique, this is unique, this is unique. Clear? So code is a prefix free. So it is uniquely decodable. Similarly for code B,
Code B is not because
yes,
one
yes,
one
yes, code B why? Which code is a prefix of another code? Can you tell, sir?
uh, one, one one and 110.
Yes, S2 code S2 is a prefix of S3. Okay, so code S2 or symbol S2 is prefix of S3. So that's why it is not a prefix free code. It is not prefix free. It is not a prefix free. Therefore, it is not uniquely decodable. It is not prefix free. Therefore, therefore it is not a uniquely decodable. It's not uniquely decodable. Now C. Code C is uniquely decodable. Yes. This code is a prefix of any other code. No. This is a prefix of any other code. Yes. This one here. It is a prefix of S3. This is no. Again, here S1 is prefix of S3. Therefore, it is not uniquely decodable and it is not prefix free. Not prefix free and not uniquely decodable. Not unique. Similarly, code D 0, it is not a prefix of any other code. This is also not. This is also not. This is also not. So code D is prefix free. therefore uniquely decodable. Yes, have you understood the concept? How we check which codes are uniquely decodable, which are not? Okay, so code A and B are uniquely decodable, and B and C are not uniquely decodable. Clear? These are yes. So, clear? Now we'll move to the problem number 2. Yes, any doubt in this one? Anyone? Okay. Then we'll move to problem number 2. So problem number 2 says, though we have considered a source X with the symbols S0 to S4 with occurrence probability 0.4, 0.19, 0.16, 0.15 and zero point 0.1 respectively. What is the average code length for the Hoffman code for this source? Okay, so you have to find the Hoffman code, find the average code length. Okay, to find the average code length, you have to find the codes for Hoffman code for each symbol, and I think you can easily find the average code. Meanwhile, I am writing the steps. What are the steps to calculate or to find the Hoffman coding? So steps, I think you know the steps. So what are the steps? What is the first step? So first we will write the code S0, S1, S2, S3 and S4 in decreasing order of their probability. Okay. So step number 1. So list the symbols. Sir has also discussed, Jagannathan sir has also discussed these steps in the video lecture. So I'm directly taking from his lecture. So list the symbols in decreasing order. Meanwhile, you calculate. I'm writing for others. You have forgotten the steps. Probability. Okay. Now, how you write? Simply, okay, I have to write the steps. So, which are already given. So, S0, S1, S2, S3, S4, S4 are there. So, zero point 0.4, yes, highest probability 0.4. Then second one is 0.19, 0.16, 0.15 and 0.1. And the next step is then you have to fuse or combine the two symbols with the lowest probability. With the lowest probabilities with lowest probabilities, and then we have to combine the symbols with the lowest probability, that is S4 and S3 and S4, and what then and add their probabilities. Then what we have to do after adding the probabilities? Let's say we have added these probabilities. What do you will get? 0.15 and zero point 0.1, that is 0.25. Now we have to assign the bits 0 and 1 to these two branches. Then step number 4, you have to assign bits, that is you have assigned, let's say 1 and 0 here. Then in the next step, what we'll do? Then we reorder the probabilities. Now we have obtained one more probability, T's, and then start from the step number 2. From step 2. Here, now we will move this 0.25. So where it lies in this order, zero point 0.4, 0.9, 0.16. So it will lie here in between 0.4 and 0.9 here. So we place this here and start from step 2. Place the symbol in the decreasing, sorry, fuse and combine the two symbol with lowest probability. So then again corresponding, I am solving this one, just giving you the idea, writing these steps. Okay, so I think you have also find the codes, which are the codes. Now I will start the solution. So S0, S1, S2, S3, and S4. So S0 is 0 0.4, 0 0.19, 0 0.16, 0 0.15, and 0 0.1. We have already first step, decreasing order of the probability. Fuse the symbols with the lowest probabilities, that is 0 0.1 and 0.25, that is probably, and add the probabilities, that is 0.25, and assign two bits, that is 1 and 0. Clear? Now place this as second step. 0.4 will be here, that will be 0.4. This will be 0.25 and 0.9, and this will be here 0.19 and 0.16. Now, which are the lowest probabilities now? These two are the lowest probabilities, this 0.19 and point. Now we'll fuse them and get one probability, that is 0.2, 0.35, 0.35, and we'll assign the symbols, that is 1 and 0. Remember, lowest is 1 and 0. Don't uh, don't give like 1 and 0. It will be wrong, because follow the same 0 again, top and bottom one. Clear? This step is clear. Now repeat the process. 0.35. Now where it will go? 0.4. It is lower than 0.4. So still 0.4 will be here only on the top position. 0.35 in the second most, and 0.25 will be third one. 0.25. 0.4 will be here, that is 0.35. So the lowest probability, these are the lowest probabilities as compared to 0.4. So we'll fuse them, add them, that will be 0.6, and assign the symbols, that is 1 0, and again 0.6. Now it will go to top, 0.4 will be here, so 0.6, 0.4. Now fuse them, get 1. Last, you have to stop when you get 1, probability 1. Clear? Yes. Symbol assigning, that is 1 and 0. Here also I will keep the so this is a tree. We have formed a tree. We have formed a tree. Now to find the codes, Huffman codes, you have to backtrack in this tree and you will get the symbol. Now what to do? To find, now I'm writing this step so it will be clear. To find the codes, backtrack along the tree to find each symbol. Means to find any symbol, let's say S4. So we'll go through this one, that is 0, then 0, then 0, that will be for S1. For S4, we have to backtrack, yes, 0, then 1, then 1. In this way, we have to backtrack and find the symbol. I will give the example. I will also find along the where we along the tree to find to to each. Okay, so S0, S1, S2, S3, and S. For S4, it would be by backtracking, it would be 0. That would be 0 here. Yes, I'm just creating for one, and you will understand. 0, 1. Sorry, I have done. Okay, 0, 1, then 1. Okay. Similarly, S3, so it would be 0, 1, 0. Understood? S2, it would be 1, 0, 0. That means 0, 0, 1. If you backtrack, you'll find, sorry, for S2, yes, then backtracking 0, 0, 1. S1, it would be 0, 0, 0. S0, S0 would be only 1. Yes, any doubt up to this point? Have you understand this concept? How we find codes or require some more explanation to this? We have backtracked along each symbol to get the codes. Okay, once again I will give for example for S1. So 0, here we'll get then again 1, 0, then here we get 0. It would be 0, 0, 0. Okay, so we'll write from here 0, 0, 0 if we are getting this one, this side 0, 0. Yeah. And we can also find the tree. So it is 0, 1. So here it would be S0, then 0, 1, 0, 0, 0. It would be S1 in this node, 0, 0, 0, 0, 1, S2, 0, 1, 0, S3, 0, 1, 1. It would be S4. Clear? So all the codes or all the symbols are at the nodes of the tree. So it is a prefix free also. Actually, Hoffman code is a prefix free code. and we can also see from by forming a tree. Now what was the question? Question was, what is the average code length for the Huffman code for this source? So what will be the code length? Code length, yes. What is the length here? What is the code length? 1, 3, 3, 3, 3. So this is the code, this is the length, and now what are the probabilities? What are the probabilities? For S naught it is zero point 0.4, that is 0 0.9, 0 0.16, 0 0.15, and now what is the average code L bar for Hoffman code would be sigma pi li equal to 0 to L bar of H would be pi is zero point 0.4 for S naught, for 0 P naught, L naught. L naught is plus pi zero point 0.9 for first one, length is 3 plus 0.16 into 3. You have to multiply this column, add them, two columns. 0.15 into 3 plus zero point 0.1 into 3. So what is the answer? Yes, anyone? What is the answer? Has anyone found the answer? So it is 2.2 bits per symbol. So that is the final answer for the Huffman. So, so we have found the codes. We have find the lengths. We have also shown a binary tree representation for the Hoffman code, and find the average code length. How to find the average code length? Okay, so this was the question. Problem number 2. Is any doubt in this one, or we'll move to the next question? So we'll move to problem number 3 now. So consider the symbol X with the source S0, S1, S2, S3, and S4 with the occurrence probability 0.4, 0.19, 0.16, same probability. Then what is the minimum possible average code length while coding for arbitrarily large block length using a prefix-free code for this source? So question is clear. What is the minimum possible average code length while coding for arbitrary large block length? So we can take any block length using a prefix-free code. What is the minimum uh, average code length we can obtain? What is the L minimum? Yes, anyone? What is the concept here? How to obtain a minimum code length? So you are allowed to take any value of the block length. Yes,
Summation 0 to m minus 1 log of 1 by pi
summation.
pkr. Summation I is equal to 0 to m minus 1
Yes.
log base 2 of 1 by pi.
Okay. This is the final one, or anything is required?
I think so. This is final.
No, it is not correct. Something is required here. I think it is required because L minimum is nothing but is approximately equal to
Entropy.
entropy. Yes.
Entropy. Okay. Okay.
Yes. So I will write one line which I have also mentioned in the video lecture. I am taking this line from the video lecture. So by coding over larger and larger block length, we will achieve the average code length arbitrarily close to entropy. So you have to calculate the entropy, calculate the minimum possible average code length. Nothing but equivalent to minimum possible average. So it would be sigma pi log 2 of pi, which is equal to zero point 0.4 log 2 of 1 by zero point 0.4 plus, just calculate with me everyone. So tell me the answer. What is the answer? You understood the concept? What is the concept here? That will be nearly equal to 2.1. It's the symbol. And you can also see this is lesser than the obtained Hoffman code. For Hoffman code, what do you obtain? In the Hoffman code, we'll obtain codes L bar is 2.2. So which is less than the Hoffman code. Okay. So this is the minimum possible achievable code length. Okay. Which is nothing but the entropy. Okay. So we will move to the problem number 4. Consider a source X with the symbol S0 to S5 with the occurrence probabilities 0.3, 0.25, 0.2, 0.12, 0.08, 0.05 respectively. What is the average code length for the Huffman code for this source? Okay, so the similar question with different probabilities, and here one there is one extra symbol S5. So this is a bit lengthy. So solve by yourself, then I will show the answer. So already I have told the steps. What are the steps? List the symbol in the decreasing order, combine the two symbols with the lowest probabilities, add their corresponding probabilities, assign bit 0, 1 to the lowest branch, then reorder the probabilities. Now I will directly write. I will not go through the steps. Directly S0, S1. So it will be 0.3, 0.25, 0.2, 0.12, 0.08, 0.0. What are the lowest probabilities? That is S4 and S5. So it is already arranged. So we have to do nothing. Just go to the step number 2 to fuse the two symbols with the lowest probabilities. That is 0.13. Okay, and assign the bits. Is 10. Just solve with me. Those who have solved, just see the answer. What is the answer? Now I will solve. That will be go between S2 and S3. So S3 will be going below here. So here S2 will be here. So 0.12. So here it will be 0.13, 0.2, 0.25. So now what are the lowest? These two are the lowest. We will combine them. Probability 0.25. Now 0.25 will be going here. Sorry. Either between S0 and S1 or between S2 and S1. It does not matter. Okay, actually, it does not matter. So here it will go. I am keeping here. So 0.25, that is S1, 0.25, 0.3, 0.2 here. Now assigning the bits is important also. 1, 0. Combine them. That will be 0.45. That will be going surely above 0.45. 0.3 will be here. 0.25 will be here. 0.25. Sorry, this is 0.3 and 0.25. So combining them will get 0.55 and 4 will be here. Further combining them you will get 1. This is the final step. So 1 0 1 0 1 0. Clear? Now we will backtrack and find the symbol S0, S1, S2, S3, S4 and S. Clear? Oops. Now S0, what is S0? S0 would be 0 and 0, 0, 0. S1, S1 would be 1 and 0. So 0, 1, we are backtracking now. Then S2, S2 would be 1, 1, 2 would be 1, 1, this is correct. S3, S3 would be 1, then 0, then 1. It's 1, 0, 1, correct. S4 would be 0, 0, and again 0 and 1. Finally, S5 would be 1, then 0, 0. That is 1, 0, 0, 1. Now length lies will be 2, 2, 2, 3, 4, and 4. Probabilities Pi 0.3, 0.25, 0.2, 0.12, 0.08, 0.05. average length sigma PILI. So multiply these and add them. Okay, now I'm not writing directly, writing the answer. So what is the answer? 2.38 bits per symbol. So it is coming out to be 2.38. When you multiply and add them, these two columns, you will get 2.38. Here I equal to 0 to 5. I hope this will be clear. Already I have taken one problem on this one, so it will be easy for you. Similar problem we have also solved. So for arbitrary large block length using the prefix free code, what is the minimum possible average code? So it would be equal to, so minimum code for minimum average code length is, for arbitrarily large block length using prefix free code is nothing but equal to entropy, that is Hx. I've already told you in the last problem, last to last problem. So I'm directly writing here. So when you calculate PIs are zero point 0.3, 0.25, zero point 0.2, and when you calculate this one, this 0.3 log 1 by zero point 0.3 plus 0.25 log Hx is coming out to be 2.36, okay, which is less than L bar, which is less than L bar for Hoffman. Sorry, Hoffman code. Now problem number 6. Now consider the same symbols with the same probabilities here. Now here we have to calculate the minimum possible average code length for a fixed length prefix free code. So what is the answer here? It is also minimum. It is also minimum possible average code length, but condition is fixed length prefix free code. Yes, anyone? Tell me. This you can solve orally. This problem you can solve orally. Yes, can anyone give the answer for this? If there is a prefix free code but of a fixed length, length is fixed, not arbitrarily large or small. What is the minimum possible code length?
It's 4.
4. No, sir, 4 is not correct actually.
No, no, no.
So, how many symbols are there? Logically speaking, how many symbols are there?
Yeah,
Total
yeah.
6 symbols.
3, 3.
Ah,
Yeah,
yes.
3. Yeah.
So 6 symbols are there, and you have to code them for a fixed length and a prefix free code. You can directly assign. You will require minimum 3 bits. Minimum 3 bits. So to code 6 symbols will require how many bits? Will require 3 bits each. Okay, so S0 to S1. So I will give you examples. So let's say 000, 001, 010, 011, 100, 101. All are prefix free code and of equal length. Okay, these are 6 symbols. If there are 8 symbols, it will also can be coded into 3 bits. If there are suppose 1, 2, 3, 4, only these 4 symbols, then it can be coded into 2 bits. Okay, if there are only 4 symbols, so they can be encoded into 2 bits, which are prefix free. Only 2 bits are required. So what is the average length? Average length will be 3 also because all are 3. So 3 into 5 divided by 5. Which is, okay, clear? This concept is clear? How we calculate the minimum possible average code length for a fixed length prefix free code. So this is the minimum. Minimum 3 bits are required. We can also code in the larger bits, but minimum is 3. We cannot code in less than 3 bits. 6 symbols. Clear? So yes, last problem. I will give you the hint only. You have to solve by yourself. So consider a source with 6 symbols of equal probability each. What is the length of the Hoffman code for this source? I've already taken 2 examples on the Hoffman code. So this you can solve by yourself. I have just give the what is the hint for this one and answer. Now you have to solve by yourself. So yes, anyone can tell me what is the probability for each symbol?
1
Yes,
by
sir.
6.
Yes, 1/6. Correct. So 6 symbols with equal probabilities, it would be 1/6, 1/6, 1/6. Now you have to follow the same procedure, combine the 2 bits and form a tree, backtrack the tree and find the codes for each symbol and find the L bar. I'm just writing the L bar, that is sigma LIPI. What is your work? You have to find the LIPI. Already PI I have given. You have to find LIPI and find the L bar. So I'm just writing the answer to verify. You can verify this one. Now tell me. And HX also given. HX would be 2.58. So try by yourself from this table. Clear? So yes, any doubt up to this point or in any of the questions? So I hope the problems will be clear to all. So, if there is no doubt, we can end this session. Yes, thank you everyone. Yes, sir. Any doubt? Krishna, sir.
No, sir, it's okay.
Okay. Okay. Yes. Thank you everyone. So we can end this session.